Now I want to talk a little bit about choosing the right reagent for what you're trying to accomplish in terms of stereochemistry. Because remember that if you add something like PBr3 to an alcohol, you get inversion. If you add tosyl chloride and pyridine, you retain the stereochemistry. Right, but also keep in mind, anytime you do an SN2 reaction, you get inversion. So what we want to think about here is if we're trying to convert the alcohol to a nitrile, to a CN group. Well, the first thing is alcohols are not good leaving groups. So really, what we need to do in either case, we need to have some good leaving group on the ring. Let's not think about the stereochemistry right now. When we have the good leaving group, we can add sodium cyanide, which will just be CN-. That will add to the carbon and displace the leaving group. Now, this reaction here is an SN2 reaction, which will happen with inversion. So no matter what, that step is going to invert the chiral center you have. So that leads us to needing to pick the correct reagent to get our good leaving group in place. You can't add sodium cyanide to an alcohol and get that to happen. We need the alcohol to be a good leaving group. So in this first reaction, if we know that adding sodium cyanide is going to do an inversion, if we want that out, we need the leaving group here to be back. So how do we convert the OH to a back leaving group? We want to use a reagent that proceeds with inversion. So I want to use PBr3. That will turn this into a good leaving group. So that step goes with inversion. The sodium cyanide addition with the SN2 goes with inversion. So the net result here is retention. So you can think of this process double inversion or retention. So if you want to do an SN2 and retain the stereochemistry, use PBr3 to invert, then the sodium cyanide, or the SN2 reaction, inverts again. In the second one, we have a net inversion. So what that means is we know the second step is going to happen with inversion. So we need our leaving group to be out so that the inversion causes it to go back. So I want to retain the stereochemistry in this first step. So in that case, I want to use tosyl chloride and pyridine. That turns the OH into a good leaving group without changing the stereochemistry. So then when I add the sodium cyanide, that's the only time the inversion occurs.